welcome to Lesson 5 of Unit 2, Derivative Rules, Part 3. Today we're going to be talking about applying the quotient rule. Okay, so let's start with a derivation of the quotient rule, like we did with the product rule and the power rule before that. I do think that seeing the derivation is helpful because you get to see the way things have come to be instead of just seeing the rule and then applying it. And the type of math that's used to prove these rules is the type of math that you might use in some upper level mathematics classes, and therefore ultimately can make you a stronger mathematician if you do choose to pursue that sort of path. Okay. So first, we're going to start with defining our function. It's defined as the quotient of functions f and g. We'll apply our definition of derivative, and I do apologize about the notation. When the tool that I use to edit equations uses a multi-line equation, it sometimes writes limits in this way. I hope that that's not going to be offensive to anybody, and that you understand this is just standard limit as h approaches 0. So first thing I want to do is to try to combine the quotients in the numerator, and I do that, or I'm going to accomplish that by creating a common denominator of g of x plus h times g of x. Once I have achieved that common denominator, I can combine those two ratios in the numerator, and then we will quickly simplify to a single fraction by multiplying by 1 over h in the numerator. Now I can pull out the two factors in the denominator, g of x plus h and g of x, as long as I bring the limit with me. And then here's where that trick is coming into play. I'm again adding and subtracting the same value. In this case, it's f of x times g of x. Notice I'm subtracting f of x, g of x, and then adding f of x, g of x. And doing so doesn't change the problem because ultimately I'm adding 0, but I get these other pieces that I can play with to try to factor things. And that's what I'm going to do. So we, in the first set of two terms, are going to factor out g of x. In the second set of terms, we are going to factor out f of x. And then I'm going to write that first limit as the sum of two limits. One that is g of x times the limit of h goes to 0 of f of x plus f of x plus h minus f of x over h, plus f of x times the limit as h goes to 0 of g of x minus g of x plus h over h. And what you'll see is that I now have two definitions of derivative that I can then apply to f and g. And the limit that, this limit here, as h went to 0, ultimately just became g of x times g of x. So simplifying things out, kind of writing things more concisely, we get g of x times f prime of x minus f of x times g prime of x. Now, there might be some confusion about where this negative sign came from. It came from the fact that this definition of derivative is a little bit backwards. So notice here we have f of x plus h minus f of x, and here we have g of x minus g of x plus h. So it's like my numerator has been switched. Those terms have been switched, but the denominator did not get switched. The difference between the x values is still just h, not negative h. So you can think about it as taking this is a smaller value minus a larger value, right? So this derivative should be negative instead of positive like we would expect. And so that negative sign comes out and becomes minus f of x, g prime of x. So The text at the bottom is really just for those who are following along in the slide deck. I had to present this proof a different way, and so if you're viewing it, the work is all sitting behind white boxes, and so really to see the proof in its entirety, you do have to watch this, like you have to hit slideshow and go through to animate those boxes disappearing. But here's our rule, the quotient rule. So given a function h of x being equal to the quotient of functions f and g, provided that g is not 0, the derivative of g is the derivative of h is g times f prime minus f times g prime over g squared. And so the way that I have always remembered this, and I to this day still recite this in my head when I am differentiating a quotient, is low d high minus high d low over low low. Low referring to the bottom function, high referring to the top function, and the d referring to the derivative. So low derivative of the high minus high derivative of the low over low low, which is the bottom times itself, or the bottom squared. So let's put it into action. Find the derivative of the following functions. So in A, we have a quotient, ratio of functions. So we'll apply the quotient rule. So we take the bottom function, or low, times the derivative of the top, d high, 2x plus 3, minus the top times the derivative of the bottom. And as we saw in the previous lesson, the derivative of natural log of x is 1 over x. Now, simplifying things a little. Okay. Simplifying things, we don't really want to multiply natural log of x into that other polynomial. It's not going to make it any more simple, but yeah. So in the next problem, we do have a quotient that's a ratio of functions, the bottom and the top, but this really just simplifies. I can divide each term in the numerator by the term in the denominator to get something that's simplified. So g of x could be rewritten as 2x plus 1 minus 4 over x. So I don't actually need to use the quotient rule because I was able to just simplify the function. And in this case, the derivative ends up being 2 plus 2 plus 4 over x squared. And of course, for minus 4 over x, I'm using the power rule there, right? That's an application of the power rule. Okay. So in summary, stay calm, learn your differentiation rules. We just added one today, the quotient rule. And also try simplifying first before applying a rule, because sometimes it may seem like a rule is necessary, but if you simplify or rewrite the function in a different way, then a different rule makes that function easier to differentiate. Thanks for watching, and I will see you in the next video.